The second thing I want to talk about this evening is unit tests and testing at Eventbrite and how we've taken this code base that's been around for quite a while and actually built a culture of testing around it. So the background of this is that historically, we started in 2007, there's no testing culture to speak of, and we started writing tests as we started adopting Django because we had to. It's impossible to change your framework without breaking something, and we needed to know when it broke. In 2011, when I joined the company, we were still doing weekly releases, but it was not uncommon for them to slip to the next week and end up being bi-weekly because we had unreasonably high levels of regressions. And this is in contrast to today, where we have a bigger team. We build on a more complex architecture that involves services as opposed to a monolithic app. We have a very robust test suite, and there are far fewer regressions. It is by far the exception these days when we actually have to slip a release by a day, let alone a week, because something happens. And this is, I think this is purely because of the testing culture we've developed. And the thing that's most gratifying to me is that there seems to be an attitude that tests matter. So what I want to talk about for the next 13 minutes and 25 seconds is how we got there and sort of what the decisions and what we had to do to get there. So what do we test? There are basically three classes of tests we have here at Eventbrite, and I think this is pretty common, so I'm just going to go through this pretty quickly. There are the unit tests that are supposed to test a discrete unit. I think of these as quote-unquote Django style, meaning that we draw a box around the unit that we're testing and our test database inclusive. So we don't try to mock out the test database. We mock out services you might call. We mock out third-party things, but we don't mock out the database. And these are actually isolated from one another in the database. So my test won't affect Simon's, won't affect Andrew's as they run. And these are ideally fast enough, and they can be fast enough to do real TDD with. We also have this integration test suite, which is similar to the unit test suite. It's almost indistinguishable if you squint. But this is what we use to test how we're integrating our services with one another. So we have an authentication service we're building. We have a payment service. These all need to integrate with each other and with the core application. And so they have their own test suites. We also want to make sure they're still operating together so that when we deploy a release that has a particular version of the payment service, a particular version of the core, we're going to get something that actually works together. And finally, there's these functional tests that we built. This is kind of the third thing we usually build when we're building a new feature. So these run they're basically Selenium WebDriver tests that we run in Sauce Labs. And these test the end-to-end functionality of the site. So can I make an event? Can I register for it? Can I buy a ticket? Can I use PayPal? All these different questions that are really critical features on the site that we want to make sure under no circumstances do we stop being, having this functionality. Another key difference here is that the databases reset between runs, so they're not as isolated. This means that they're slightly more fragile. They can, one failing test can impact a whole bunch of other ones, and so it's just important to keep that in mind. So how do you take this existing code base that I think was about 300,000 lines of Python when we started this process and start testing it? The issues that we really saw here are, as we look back to the last couple of years, when you're writing tests and you're doing test-driven development, those tests guide how you write your code. If you're committed to writing tests for it, you're going to write your code in a certain way. You're going to write views that just handle the view. You're going to move things into methods because it's easily testable. But when you have untested code, it often grows organically, and so it's hard to understand what the intended behavior actually is. So what we found really worked for us was working backwards. We started with these very high-level end-to-end functional tests, and these are sort of our canary in the coal mine as we started developing a culture of testing. So these are the things that would let us know, have we done something that's going to make it impossible for somebody to register for a PayPal event? Have we done something that breaks the site for people in French? That sort of thing. These are sort of the least valuable overall in some ways, but they're by far the most reasonable to write when you're starting from scratch and you have a whole lot of code already. We also set the expectation that when you wrote new code, it was going to be tested. So this gave people not only practice in composing tests, but helped build the necessary skills for the team before we could really tackle refactorings. And finally, we really celebrated these sort of small wins. So when somebody took like a five lines out of a 900-line function and made it its own tested thing, that's great. That's a huge success for us. 3 years ago, because it meant that we were on track to a culture of testing. So what gets in the way? The environmental differences is something we found that was really we really had to address early on. And the way we addressed this is like the differences in your environment between testing and development and production. I think a lot of people do this. We use a CI system, Jenkins in our case. And the thing I want to point out here is there's a whole bunch of different jobs that run here, but this EB Core, you probably can't see this EB Core build job is the one that we run first when you make a change, and the artifact from that is a tarball with all the code, all the dependencies, and that's the exact same artifact that we're going to test, and that we're going to deploy, and that we're going to end up shipping to our production servers. So this is a change we made that makes sure that we can, that we're testing the same thing we're going to deploy. Right, it also, those functional tests are slow, and so this helps mitigate that a little bit that we're running in a central place. We also found that we had code that would change settings under the hood that's not so great, and that made tests pass in isolation but wind up failing when we ran the entire suite, which is kind of a bummer. And also because I might commit some code that seems like it works just fine, but somebody else's test or somebody else's code that I'm calling changes the setting. And so what I did was I wrote a Nose plugin for this. We use Nose to drive our test runs here, called Settings Guard, and we're gonna put this up in a gist because it's really simple, but this is a sort of a condensed version of it. Basically all it does is it stores a bunch of initial states and then does a bunch of assert equals at the end. And this just makes sure that if a test is mutating something, it gets caught. The test fails. You can't write, so this made it impossible for people to write tests that called code that was going to mutate settings. It doesn't make it impossible to write that code, but combined with a culture of writing tests as we write new code, this was actually very, very effective. There were times that it's also uncovered things where people start testing code that hasn't been tested in the past, and so they realize that it has some pathological behavior. The other sort of barrier that we had as we started doing this testing was that we have multiple languages like most places. There's Python and JavaScript here, and we wanted to start writing tests for our JavaScript code as well, but give engineers a single command they could run to sort of do the entire suite. So what we end up with here is we're using Jasmine for our JavaScript tests, and we have a Jasmine test case that uses Nose parameterized to blow this up and run. Basically, it does a sub-process with Phantom.js and then searches for the failures and raises them inside of Nose. This is a total hack, but it makes it really easy for people to run a test suite and make sure they haven't broken anything. Finally, there's this issue about performance. When you have a code base as large as ours and the tests we've written for the older code in particular tend to be slow, we need to figure out how we can let engineers go faster than they might be able to otherwise. So another member of the team, Al, wrote this plugin called Nose, and basically we run this nightly on our integration server. It records what code every test touches, and then you use that file, and you can basically say, hey, I changed the SQL utils checkpoints file. Run every test that's going to touch that for me. And so this is a way you can do more than just run the test for a particular package. You can run all the tests that touch something really easily. And this is available on GitHub. So it's never too late to start testing. It's important that you can add tests in reverse as if you're going to start doing this, starting with the functional tests, and figure out what's stopping engineers from testing. These are the things that you can actually address and help build a culture of testing around an existing code base. Thank you.